In section 6.2, we learned how to set up a linear programming problem. And so in section 6.3, this is where we learn to actually solve the linear programming problem. We know that we can solve this type of problem using the concept of Theorem 1, which says that if a linear programming problem has a solution, then it must occur at a vertex, or in other words, a corner. And so we can solve the linear programming problem by using the method of corners, which tells us to step 1, graph our system of linear inequalities. Step 2, find all the vertices, in other words, the corners. Step 3, evaluate the function at each corner. And then finally, step 4, find the vertex that renders a maximum or minimum. So in this example, they've already done, as you can see, steps 1 and 2 for us. They've already graphed our system of linear inequalities. They've also labeled the vertices. And so we can skip down to step 3 in a problem like this, to where we want to evaluate the function at each corner. So we're going to take each corner and plug it into our function. And so we're looking at the number that we get after plugging in our vertices. And whichever one is the smallest number is going to be the minimum. Whichever one is the largest number is going to be the maximum. And now we may not always get a minimum or maximum. That all depends on whether the set is bounded or not. And in this example, we do have a bounded set. We'll look at an example in the next video to where we have an unbounded set, to where we don't have a maximum. So as we continue plugging in these numbers, and we're plugging in each set into the same function, again we're looking for the largest value that we get and the smallest. And after we find all four of our numbers, then we can compare those. And we're saying that the largest number is the maximum, so our maximum is 35. And our minimum is 5. And that would be our answer to this type of problem, to where they ask you to find the max and or the minimum.